This video goes over question 1 of the business optimization assignment. A company manufactures and sells X cell phones per week. The price, demand, and cost equations are given below. So our demand function is P of X equals 400 minus 0.5X. And cost is 15,000 plus 135X. So in the cost function, the fixed cost is $15,000 a week, and then our variable cost per phone is $135. So our demand function is a downward linear with negative slope. So the y-intercept or P of x-intercept is $400. And if we figured out the x-intercept, it's going to be over here at 800. So as the price goes down, demand goes up. And then we're going to need the revenue function. Revenue is the number that you sell times the price you sell it at. And in this case, it's going to be x times 400 minus 0.5x, 400x minus 0.5x squared. So that's going to be a downward-facing parabola. And then our real object in running most companies is to maximize profit. And profit, and I abbreviate that as PR of X, is the revenue minus the cost function. So what price should the company charge for the phones, and how many phones should be produced to maximize weekly revenue? What is the maximum weekly revenue? The company should produce blank phones each week at a price of blank. So they hadn't really asked us what the revenue is, so that's going to be a follow-on question. Now I'm going to show you how to do it in the calculator. So I've already put in the price function, and I'm going to show you how to do that in a new problem. Doc, 4 for insert, 1 for problem, 2 for a graph. So I'm going to put in P of X, and I can change the name of the function. So P of X equals 400 minus 0.5x. If I'm just doing this problem for no explanation, I really don't care what the window is. And if I want to immediately put in another function, I can just hit down arrow instead of enter. Now I'm going to put in the cost function that the problem gave us. So that's C of X equals 15,000 plus 135x. And I'm going to put in revenue next. So I just down arrow to put in another function. R of X equals X. And in this calculator, if you're going to put 2 letters together and imply multiplication, you need to put in a times sign. So X times P of X. So this is our demand function. And I'm going to do, the last thing I'm going to put in is profit. So PR of X equals the revenue function of X minus the cost function. And we always need to put in the X. If you don't put in the X, you'll get an error. So right now, I don't have a good window. I already put in a good window for the previous problem. So here is the demand function. My y-intercept is 400. My x-intercept is 800. So if you're worried about setting the window, I want to see the y-axis, so I want a little bit negative, negative 200 to 900 by hundreds, and then negative 100 to 500 by 50s. So that's a pretty good picture of revenue, or the demand function there. And then we got the other three functions here. Here's the revenue function, here's the cost function, and here's the profit function. So profit is revenue minus cost. So about right here is where the vertical distance between the revenue and the cost is the greatest. And that's actually what you want to maximize. So I'm going to go back to that other problem that I started. So I've got the 4 functions here. If you want to get back to them, you hit tab in the graph page, up arrow, and that gives me the first renamed function that I put in. Now I want to see the other 3, I hit down arrow. So those are the 3 or the 4 I have. Control Doc to put in a calculator page. I want to take the derivative of revenue because I want to maximize that. Control the shift minus, put in the X, tab to get to the next rectangle. Revenue is a function of X. So 400X, menu algebra 1 to get a solve, set my marginal revenue equal to 0, and solve for X. So that tells me I need to make 400 phones to maximize my revenue. So we'll go put that in, 400 phones. And then what do we need to charge as the price? So we're going to go back to the demand curve. P is a function of 400 is $200 a phone. We'll check that answer. Nice work. Now they're going to ask us the revenue. Two different ways we could do that. We could just multiply the number that I'm selling times the price and get 80,000. But we have the revenue function here, so revenue at 400 is 80,000. 80123. Check that answer. Excellent. What price should the company charge for the phones, and how many phones should be produced to maximize weekly profit? What is the maximum weekly profit? So now we're going to go to maximize profit, we're going to set marginal revenue equal to marginal cost. We already did marginal revenue, the derivative of the revenue function. So I'm going to go up to this calculation and replace the 0 with my marginal cost. And since my cost function is linear, the marginal cost, or the derivative of the cost, is just 135. 135. So I need to manufacture 265 phones for maximum profit. So fewer phones for more profit. Then what should my price be? That's the demand curve. Price at 265 phones should be $267.50. $267.50. And even though it says round to the nearest cent, we can leave it at 0.5. Or you can put in 50 if you want. Excellent. And then the maximum weekly profit is, so this is not going to be revenue. So we need to go to the profit function, profit at 265 phones, 265. So that's going to be 20,112.50. So 20,112.5. Check answer. And before we go on to the next problem, we're going to go look at the graphs for a second. So I'm going to go back to my pretty graph here. If we were in Algebra 2 or pre-calculus, we could find out max revenue, production, and the max revenue by finding the maximum of this parabola. Menu, 6, 3 for maximum. Which graph? Well, I got 3 here, so the calculator knows. Well, you want the maximum, which one? So we're going to click on the revenue, lower bound, upper bound, and it says 399.999, so it's really 400, and our revenue is 80,000. And if we want to maximize the profit in Algebra 2 or Pre-Cal, menu 6.3, this graph, lower bound, upper bound. And we see it's 265 phones, $20,112.50. So we got the whole question right. That concludes this video.